Welcome to module 2 of Python by Craft Knowledge. Module is called variable, data type, and operators. Before we move on, let's quickly have a recap. So in the last module, we briefly talked about this course, the hierarchy of this course, what is going to be the structure of the modules in this course. Then we talked about Python, why Python is important, why nowadays Python is booming. And finally, we set up the environment, the IDE called Jupyter Notebook. And in next video, we are going live for coding. So before we go live for the coding, let's quickly have a look on the objectives. So in this module, we are going to talk about the input and output, how we can take input, how we can output different things in Python. We'll talk about what are the variables. We'll talk about the data types. We'll talk about arithmetic operators, comparison operators, logical operators. Now you might be wondering that what are these operators, right? So as if I tell you very briefly, obviously we are going to study these things in much details. So arithmetic operators are just like mathematical operators, where we can do calculations like multiplication, like addition, like subtraction. Comparison operators, as name suggests, it used to compare different variables, or you can say, no, you may be asking what are the variables. So you can say it is used to compare different values, right? So if we have two or more than two values, we can compare which value is bigger, which value is smaller. Finally, we have these logical operators that helps us implementing the logics, right? So let's jump into the input and output statements. Every programming language has two main things, that is the interface where user can input something and an interface where we can output something to user. We can explain something to user. For example, here in Python we have this print statement or print function that helps us print or output anything for the user. And we have an input function in Python that helps us to ask for the input from the user, to ask for the user's opinion on anything by using Python. So let's explore it. Let's see how we can use this print command, print in lowercase letters, and then we have these parentheses. Now you might be asking that what are these parentheses? I would request you guys to wait for a while. I'll explain what is this thing. In short, you can say whenever we are writing a function, these parentheses are denoting that this is a function. Now, what is a function? I'll define it later on. Right now, I would request you guys to just follow me along, right? So we'll say print and then the parentheses, and inside these parentheses we will write anything that we want to output for the users inside these quotation marks. If that message is in English, then we need to write these parentheses, right? And if that message is in some digital form, digits, let's say 10, 20, 30, then we do not need to write these quotation marks, right? So let's go into the coding environment. So this is the Jupyter Notebook that we installed in last module, and here you can see this new button over here. We'll click on new. There are a few options. You need to select Python 3. So we need to create a new Python notebook for Python version 3. It will take a few seconds, and here we go. So here you have the environment, and this is called a cell, right? So you can have multiple cells over here. All you have to do is you have to click on this plus button, and you can get cells over here, right? Okay, so now I'll explain all these options with the passage of time, right? So if I'll explain all these options right now, you can say overloaded with the knowledge. So I'll explain these options one by one whenever any option is required. So if I want to output something, I would say print, okay, and then these parentheses. The moment I completed this word print, it turned into green color. Why? Because it was predefined. Predefined means that in Python, it has some predefined definition for it, which means that whatever I will write over here, so its predefined definition says that whatever I will write inside these parentheses, that is going to be output, right? So if I'll say, and whenever you start learning a new programming language, there is a convention. The first program is always going to be hello world. So hello world. So just to follow the convention, we have also written print hello world. And then in order to execute this command, in order to execute this cell, actually we need to select the cell. You can see it is selected in a green rectangular box, which mentions that this cell is selected. If I'll click over here, now this second cell is selected. So I'll click over here, the first cell is selected. Now we have a run button over here. We'll click on run button, and here we go. So whatever I wrote over here, it has been executed and the output is here. Now if I want to say, let's say I want to say hello to my dear friend, so I'll say hello to my friend. I don't want to say hello to the whole word. I'm a bit conservative, so I'll say hello to my friend. Cool. And you can say anything over here, and it will be it will be executed as it is. Okay. Now what if I need to output some number? Then you do not have to use these parentheses. You can right away write, let's say you go ahead and write 10 over here. So print 10. Yeah, it is executed. You might be wondering that I'm not clicking this run button, but still the statements are executing because I'm using a shortcut that is called control plus enter. So if you will hit both of these buttons together, it will be executed. It will act just like you have clicked this run button. Cool. Okay, so now what if I want to say just let me copy this. What if I want to say I have 10 mangoes? Cool. I think spellings are wrong. I don't know. Okay, so now this is a combination of digits and English letters. So if it is a combination, then I'll have to encapsulate it inside these quotation marks, right? I have to make it a string. Now what is a string? We'll see. So I have 10 mangoes. You can write it like that. You can also write mathematical expressions as well. What if I want to say 5 plus 1, that is 6. If I run it, it says 6. You can also write any complex equation over here. And one more thing, if you just want to print something, you just want to output something, you don't have to, if you want to output only one thing in one cell, then you don't have to use this print statement. If you have to output multiple things in one cell, then you'll have to use these print statements. For example, if I'll say I want to output 5 plus 2, right? I'll just write it as it is and I'll execute it. It will be outputted. But what if I want to output 5 plus 2, and apart from that, I also want to output 9 plus 1, right? Now only last line will be executed for output. Obviously both of lines are executed, but the output will be only for the last line in the cell, right? So if I want to provide output for both of these lines, then what I have to do is I'll have to write print statement twice. So 5 plus 1 and 9 plus 1. So now you can see that the output is over here for both of them. Moreover, you can write very complex equations as well. Let's say 9 plus 1 minus 2 multiplied by 6 its power 2. So this static sign represents the multiplication, and double static sign represents the power sign, or you can say exponential sign, right? So if we have an equation like this, which is a complex equation, right? So let's say divided by 3. So how is it going to be executed? If I run it, and you pause this video over here and try to figure it out, how this result is calculated. Okay, so if you don't want to use your brain, then use this slide. So here I have written the order of operations. So first of all, parenthesis is going to be solved. Then second number is for the exponential or powers. Third number is for multiplication, division, and reminders. You might be asking that what if multiplication and division are in the same equation? Then it will give more priority whatever comes first from the left hand side, right? It starts execution from the left hand side, just like English. Just like English writing. And then at last we have addition and subtraction, which means that addition and subtraction has the least priority over there in any equation. Cool. So this is how we can output anything. Now talking about input, just like output, we have a method print. For input we have a method called input with a similar name, right? And since it is a method, it is a function, so we'll have to write parentheses in front of it as well. So let's go ahead and see how we can input anything. So very simple, we'll say input. You can see it has turned into green color, and inside it we can give a prompt message. So we can say enter a number, right? and then we'll have to run it, and here we go. It is printing out the prompt message, exactly this message. You can change it according to your need. And then here we can say, let's say the number is 12. Then we'll hit enter, and here we go. Cool, very simple, very easy, but there is a problem. Let's say we have a program where we want to ask 100 users for their ages, right? So if I say enter your age, cool. Okay, so if I run it, so it says enter your age. I'll enter my age, 22, which is not correct, obviously. So it will obviously take 22 as an input. But the thing is, it is taking input and storing it where? It is storing it nowhere. It is just executing it as it is. It is not storing this value that is entered by the users. Now what if I have only one user? I know what is the age of this user, but what if I have 100 or maybe hundreds of thousands of users? Then I'll have to store the value somewhere, the input value somewhere. Or what if I'll have multiple equations to execute and I want to save their values? So there has to have some storage mechanism in Python. So is there any storage mechanism? Think about it, and I'll say yeah, there is a storage mechanism that is called variables. Now variables are the thing that help us store the values. Well, what are the variables? So variables are basically the containers to store values, which is a book definition. We can throw it away. So let's compare variables to a human brain. Let's see the mechanism, how human brain stores the information. So let's imagine this is a human brain, right? Looks like quite empty brain. Looks like a brand new brain, right? So what if we need to store some information in our brain? Let's say I need to store the age of myself. Let's say I am 20-year-old, quite young. So I will store that information, that 20, somewhere inside this cell, and I'll keep updating this cell of my brain. After 1 year, maybe you'll ask me what is your age. I may say 20 again, but no, I'll be 21. So I'll update the information in my brain cell, and so on. So the information in our brain cells is basically, it was basically the motivation behind these variables thing. So the way we store different informations in our brain, we want to replicate this process for the programming languages. One more thing, we store multiple types of data into our brains. For example, if I ask you what is your age, the answer will be probably a digit. If I ask you how you look like, so you maybe have yourself in your mind in a pictorial representation. If I ask you how your father looks like, so maybe you'll have a picture in your mind, right? If I ask you how was your trip to the mountains, maybe you'll have some video representation, some moving pictorial representations in your mind, right? So what if I ask you how rose smells like, the flower, the flower of rose? Maybe you'll have you'll not have some pictorial representation in your mind. You'll have the representation of smell in some different manners, right? If I ask you how your new shirt feels like, is it soft or hard or what? So maybe the information that you have stored about the feel of your shirt will be stored in a different manners. So since in our brain the information is stored in different types, same goes out with programming as well. So in programming, if I want to store the age of the user, I need to store it in some variable. So variables are basically, you can say, the brain of the programming, that part of brain where programming is going to store the data, right? So variables can be updated. Obviously the brain cells, the brain cell where I'm storing my age can be updated. Obviously the brain cell where I am storing my image, let's say I have a beard and now I'm a clean shaved, so I can update my cells, right? So variables can be updated, most of them can be updated. So we have different types of variables. For example, we have numbers, and we have two types of numbers: integers, positive, negative, and then we have floating point numbers, complex numbers, different types of numbers. We'll talk about it. And then we have strings. So strings are basically the sequence of characters. Now, what are the characters? Anything on your keyboard that you can see, that you can type, is a character. That is one character. So if you will combine multiple characters, that will become a sequence of characters, and that will become strings. Yeah, you know what it is? It is simply a hello world that we printed last time over here in coding environment. You can see, for example, here, hello world. What it is? It is just a sequence of characters. H is one character, E is another character, and so on and so forth. So it is just a combination of different characters. That is a string. And now you might be wondering that what is this quotation sign? So this is a representation of string. It basically represents that, this quotation mark represents that a string is starting from here and it is ending over here, right? So that is why we add these quotation marks. This is a symbol of string. Cool. Then we have list as well. What is list? So list is basically the ordered collection of items. So what if we have multiple numbers to store? Let's go back to our previous example of storing ages of 100 users. So if you want to, in one integer, we can store only age of one user. So what if we want to store the ages of 100 users? So we need to store this ordered collection somewhere. So that can be stored in lists. What are the tuples? Tuples are just simply the lists, but they are immutable. What do we mean by immutable? Immutable means that they cannot be updated. So lists can be updated, but tuples are simply the lists that can never be updated once they are defined. Then finally we have dictionaries. Dictionaries is nothing, just a key value pair where a value responds to a key. Right now this might be not very much clear over here. We'll talk about dictionary in much detail when time will come. Cool. Okay, now let's have a quick representation. Have a look on the representation of each data type. Let's say these are the integers, right? And now you can define integer like this. First of all, you will write the name of the integer, that is called identifier. So there has to be a unique identifier to every variable. For example, the age, that is an identifier. So age equals to 25. The quantity of something equals to 10, right? So these are the integers. It can be negative, it can be positive. Then we have the floating point values. Temperature can be 98.6. Value of pi can be 3.14, or any value that comes in floating point that will come under the umbrella of float. These both data types are called number data types. Integer and float are the number data types. Then we have list. So as I mentioned, list can store multiple other data types. For example, the numbers 1, 2, 3, 4. So it is storing, this list of numbers is storing multiple integers. Here the list of fruits, it is storing multiple values or multiple variables of strings. You can say apple is a string. So A-P-P-L-E, these are the character. A is a character, P is a character, and apple is a sequence of characters, right? So let's go back to the strings. Over here you can see, as I defined earlier, so let's say name equals to, here you can see these quotation marks, right? So these quotation marks can be double quotation or single quotation, does not matter. There is a slight difference that I'll explain later on, but there's not much of a difference. You can use either of those. So name equals to double quotation marks, and then you can write any sequence of character over here. Greetings, hello world, again quotation mark, and then sequence of characters. Then we have a Boolean data type as well. That is the, you can say, the cutest data type that has only two values. Either it is true or false, but it is cute, but it is very useful in Python. It helps us in making comparison operators, in making logical operators. Then we have tuple. As I explained earlier, tuple is simply a list but is immutable. List is changeable. Tuple is not changeable, right? Once the tuple is defined, the values are going to remain same. You might be wondering that then what is the usage of this tuple? So what if you want to define something that you want it should never be changed, right? Even if I want to change, if someone wants to change, they should never be able to change. There are something called constants that you never want to change. For example, the value of pi, you never want to change the value of pi, right? So and the last two data types are actually three. We have dictionary, where we can store multiple values in pairwise fashion. For example, name colon John. So now name is going to be the key and John is going to be the value. Age colon 30, so age is going to be the key and 30 is going to be the value. Now how can we access different data inside these dictionary, inside these lists or tuples? We'll talk about it. Then we have a set. So set is, again, you can say it is simply a list, but it will not store the duplicate values, right? So the definition of set is typically the definition of set is there in mathematics. In mathematics, set is something where there will be no duplicate, right? So in this set there can never be a duplicate. And finally we have another data type called none. So basically when there is nothing, there will be none, right? So I know if you're getting just 5% or 10% idea of what are these data types, what are these variables, that is more than enough, because we have not gone hands-on so far, and enough of theoretical stuff for now. We are going hands-on, and we are going to implement almost every data type in Jupyter Notebook from now to onwards. Okay, so coming back to the problem where we started, so we were taking input from the user, but we were not storing it anywhere. So let's do it now. So first of all, we'll say we'll say input, and here we'll say enter your age, right? Now user will input something and we need to store this input somewhere. So we'll say age equals to this. So now age is basically the identifier, the variable name of whatever is going to be input over here. For example, if I say, let's say number, num stands for number, num equals to 10, right? So if I say num1 equals to 10, and then I'm gonna say num2 equals to, let's say 20, right? If I run it now, here if I say print num1, so what is going to be the output? Output is going to be 10. Why? Because num1 was the identifier of value 10. This equal to sign, that we in mathematics we call it equal to sign, but in programming we call it assignment operator. So basically what it does is it assigns the value that is on right hand side to the identifier or to the variable name that is there on left hand side. I repeat, value on right hand side will be assigned to the variable on left hand side. Cool. Now what if I say print num2? What is your guess? Is going to output 20, right? Because 20 was assigned to num2. We can also do something like num2 plus num1, right? What is going to be the output? What is your guess? What if I say so print 10 plus 20, right? So if I run it, it is going to output 30. Now what if I run this one? It is going to output 30 as well. Why? Because num2 is 20 and num1 is 10. Cool. I'll come to these arithmetic operators later on. So here this input is basically getting the age from the user, and now when this function will be executed, when the execution will be done, the value that will be entered by the user will be replaced by this function over here. So this is on the right hand side. So basically we are not assigning this function to age variable, we are assigning the value that will come after the execution of this function. The value will be assigned to the age variable. Cool. And then here let me say print age. So here we'll print age. Let me add a cell. Oh, okay. So if I run it, so it is asking me for the age. My age is 12. I hit enter, right? Nothing happened. Now here if I execute this, it says print age, so age is 12. And I can do something like this. I can output a string and an int. I can execute multiple values at the same time. For example, what if I want to say my age is whatever is the user entered? So if first of all I will write these parentheses. So I'll say the age of the user is colon, and then after these quotation marks I'll hit comma and then the second value. Cool. Now what is going to be the output? Here we go. So this thing that is in string is there in the output as it is, and the second thing that comes in the output is basically the value of age. Let's write it in same cell so that we don't have to run it again and again. Okay, so now if I run these two lines of code simultaneously, what will happen? I'll hit run button. First of all, it has executed this line and it is asking for input. Now here this static shows that the code is still running because it is waiting for the input, right? So it has not executed this second line. Why? Because it is still stuck at the first line. It will not move on unless I'll enter the age. So if I'll say, let's say my age is 30 and I hit enter, here we go, the age of the user is 30. Cool. So this is how you can store the values in the variables, and you can store multiple ages and multiple variables. Let's say this is going to be the let's say my name is Zia, so Zia underscore age. You may want to ask about the age to Chris or Alex, so you can do something like that as well. So what if I say Zia space age, right? If I run it, here we go, it gives me the error. It says that syntax error. Syntax error means that you have done something wrong, you have messed up with the rules of Python, right? And it is also mentioning that here you can see this error, right? So it says that here, I think here is something going wrong, which means that there cannot be space between the variable names. So if I want to say Zia age, I need to write Zia underscore age, right? Just like the Twitter hashtags. Cool. Okay, and there are different set of rules for naming the variables that we'll talk about in next lecture, right? Apart from that, again it is asking me, so let me add 12 over here. Moreover, talking about the numbers more, you can store the numbers and later on you can perform arithmetics on these numbers. For example, here, what if I want to store the result of num2 plus num1 somewhere? Here I'm just outputting it. So let's say I want to say result, or maybe you can say sum underscore result, right, equals to num2 plus num1, right? If I run it, and now if I say sum underscore result, right, if I want to output it, what is going to be the result? Obviously 30, right? Cool. And what if I would say POW underscore result, which means the power result, right? So basically what I want to do is I want to say num2 raised to the power. Now it is not really important to always have the variables in the equation. We can have the constants as well. So what if I want to say num2 raised to the power 2? What is the num2 basically? Num2 is 20. So 20 raised to the power 2 is what? You calculate, I'll execute meanwhile. Right, so I'll say power underscore result. So that is 400. Cool. This double static is for the exponential operation. So here we go. You can implement almost every arithmetic operator over here. So this is going to be your homework now. Before you go to the next video, you have to implement addition, subtraction, division, modulus, I mean all the arithmetic operators that we have not implemented so far. Let's talk about strings now. So let's say this is a string. Let's store it somewhere. So let's say we have w1, which is the word 1. Okay, so that says good. Okay, and we again have a word that is word 2 that says morning. Cool. Now okay, go ahead and you need to guess what is going to be the output of this thing. If I output w2, what is going to be the output? Yeah, that is going to be the morning. Cool. Now here's a trick question. What if I will put the quotation marks around w2? Now what is going to be the output? If I run it, the output is going to be the w2. Why? w2 is a variable which is basically the identifier that is identifying this string morning. Then what is the difference if I put these quotation marks around it or not? So when I put quotation marks around it, the Python will consider this thing as a string itself, right? It will not consider it as a variable. And when I remove these quotation marks, then it will consider it as the variable. Cool. Okay, now I'm gonna do something stupid, really stupid. So what if I say w1, which is what? Which is string good, okay? And I'll do something like w2. Oh, you would say, really? w1 plus w2? Are you gonna add up these strings? How is it gonna work? Okay, I know 2 plus 2 is 4, it works in digits, but how is it gonna work for the strings? Let's see. Here we go. So basically, if we'll use plus sign for the strings, it combines those 2 or more than 2 strings, right? So there's no actually no space between good and morning, right? So what if I do something like, again plus, and here these quotation marks, which is a string, and inside it I will just write a space, an empty space. And let me tell you, that is a fun. This empty space is also a character. In programming, there is nothing you can say useless, right? So this empty space is also a useful thing. So now if I hit run button, and you can see w1, which is good, okay, it is adding up this space string over here, and then it is adding up the morning over here, right? So you can make your sentence. So let's say if I can also store it somewhere. Let's say S stands for sentence. Let me make it sen, right? So now if I output sen, it is going to output good morning. Cool. You can also implement different built-in functions for string as well. For example, there is a method called length, right? That is built-in method. So if I say len, not complete length, you can see it has become green, and I'll pass the string into it. It will output the length of the string. So if you will count the characters inside it, there are total 12 characters. Go ahead and count them. Yeah, you're right, these are 11, but if you will count the space as well, then they will become 12. Cool. Okay, what is going to be the length of w1? So g-o-o-d, that is going to be 4. Cool. So you can check out how many characters are there inside your string. And again, I repeat, it is going to count the spaces as well. Space is a valid character. You cannot ignore space. Okay, what if you have a complete string, but you just want to output a chunk out of a string, not the complete string? For example, if I want to output only good, right? So I need to slice this string, right? This is called string slicing. So how it works? You'll have to write the name of the string, right? And then you'll have to write these braces, right? These and then here you'll have to mention the indices. Basically, this is index is basically the position, right? This is the position 0. And remember, always in programming, counting starts from 0, not from 1, right? So this is index 0 or position 0. This O is index 1, this O is index 2, this D is index 3, and so on and so forth, right? Okay, so I want to print only good. So good starts from G, that is index number 0. So I will say start from 0 and then colon and end at D, right? So D is at index number 0, 1, 2, 3, right? Index number 3. And if I will write just 3 over here and I'll run it, here we go. But it has ignored D, which means that it does not include the last index. So if I want to print good with a D, I'll have to write 4 over here, right? Now it is printing good. Cool. Okay, there's another way. I can also mention that. Okay, go ahead and print a sentence from starting till 4th index, right? If you're gonna start from the beginning, then you do not have to mention 0 over here. It will automatically assume that you're starting from very beginning, right? And if you're gonna go till end, right? So I'll say I'm starting from 4, which is going to be this space, empty space, and I'm gonna go till end. So here we go, space is there and then the morning. Cool. So this is how the slicing will work. And then we have a lot of different methods, a lot of different functions that work with string. Let me add a few more cells over here. For example, if I want to find out how many O's are there in the string, right? So my string is basically this, good morning. So I'll say sen dot, right? So dot basically mentions that I'm gonna use some functions of this string, right? So I'm gonna say count, okay? And here, since it is a function, so these parentheses mentions that it is a function. And then here I'll mention O, so I want to count O's. So there are 3 O's, 2 in the good and 1 in the morning. Okay, what if I write the capital O? It will say 0. Why? Because this is a case sensitive thing. So there is 0 capital O over here in this string. Cool. Moreover, you can also use find function as well. Sentence dot find, and let's say I want to find the location of R, right? So it will return the index, the position where R is, right? So it is at 7th index. You can count it at your own, obviously. So this is how you can implement different function, and again you can also implement another function, interesting one, that is called upper. Okay, sen dot upper. So it will convert all the characters inside this string to the uppercase. You can also use the lower method as well, lower. So it will convert all the characters into lowercase. Now you might be wondering that how many methods are there and how am I going to remember all these methods? Don't worry, ask for help, not to me but to the Python. So you can use this help method, and inside this help you can just say, let's say I want your help on string data type. I want all the methods that are there in string data type. So if I run it, here we go. It will open up a small documentation over here that is not very small actually. So here you can see different functions, different methods that are there in string, and you can use any of those anywhere. Let's use one of those. For example, this ends with, that is a method in string, right? Let's go ahead and use it. So if I say sen dot ends with, and here, so sen, remember it is a string that says good morning, right? So here it will, I can check it out. You can read out for the definition as well. So you can say if this string ends with G, if I run it, it says true. Yeah, it ends with G. Okay, tell me if it ends with A, it says no, false. It does not ends with A. Okay, tell me if it ends with morning, it says true. Okay, if I say it ends with morning with a small m, no, false. So you can check it out whether it ends with any character or any substring or not. There's another method called starts with, right? It is self-explanatory what it does. So you can check out different functions over here. The definitions are also available, and it is fun. So your assignment is go ahead and explore these methods, what these methods are doing in strings. So far we have talked about integers, floats, and strings. Let's talk about some large data structures now, just like list, tuple, right? So basically the main difference between integer, float, string versus list, tuple, and dictionaries is the following. In integers we can store only one value. In float we can again store only one value. In string we can only store one sequence of characters, not one character but one sequence of characters. But what if we want to store multiple sequences of characters? What if we want to store multiple integers? What if we want to store integers and multiple sequences of characters and multiple float values as well? Then we have list that comes into play. List can store multiple data types in it, just like this. All you have to do is you have to put these these braces around the values, and you can store as many values as you want. Yeah, things are not very much clear. So let's go to our Jupyter notebook and let's quickly talk about list. So first of all, how can you define a list? Let's say if I say LST, and first of all you need to put these round, again I keep saying round, these square brackets over here, right? So these square brackets are the symbol of list, right? And then you can put as many values over here as you want, and these values don't have to be in order. So you can put 12 over here as well, and you can put maybe 9 over here as well, and that's it. And then if I say LST, so here we go, you can print it out as well. And just like string, you can also go to individual indexes as well. In the strings, if we go back, so for example this is a string morning. If I say string of index of 0, that gets me this m, right? So same goes out over here. If I say LST of 0, it will get me 1. 1 comes from here, right? Now you tell me what will be the output of this line. So it says list of index 3, so 0, 1, 2 and 3. So output is going to be 12. Cool. And again, you can also work with slicing as well, just you did with a string. So you can also say something like, so get me all the values from index 1 till index 4. So which one is index 1? This is 0, this is 1, right? So from index 1 till index 4, so 1, 2, 3, 4. So this is index 4, but we know that the last index is not included, right? So it will only output this part. So if we run it, here we go. Cool. Moreover, you can also have a list that will be, you can say, a mixture of numbers and strings, right? So for example, here I say 1, 2, 3, 4, and here I want to add a string. So let's say my string says apple. Cool. And let's say this is going to be my LSD1, right? Because LSD was this and this one is LSD1. Okay, and if I just output it, so it looks like this. Now you tell me, what if I say LSD1 of 0, 1, 2, 3. So if I say LSD1 of 3, it gets me apple. Cool. Now listen to this thing very carefully. What is LSD3? This basically this thing is a list, but if I do something like this, now it becomes a string. Okay, and we know that we can further index a string. So what if I want to access this L? I can simply add another indexing bracket over here, and I can say 0, 1, 2, 3. Yeah, 3 again. So it will get me L. Cool. So this is how you can approach any member. These are the members of the list. You can approach any member of the list by using the indexing operators. Moreover, since this is a mutable data type, so you can change the values anytime. For example, if I want to say I want to change this, I want to replace this 4 with 40, right? So I'll say LSD1 of, where is 4, 0, 1, 2. At second index, I'll say LSD1 of second index is going to be 40, right? And then if I say LSD1 now, so here we go. You can see that 1, 2 and 4 is replaced by 40, and so on and so forth, right? So this is a mutable data type, which means that after you have declared the data, this is called data declaration. After you have declared the variable in the data in the variable, you can update the values of your data like this, simply. Cool. Now this is list. I said tuple is also the same thing as list. The only difference is you cannot do something like this. You cannot update the values in the tuple once the values are declared, once the variable of the tuple is declared. So let's define a tuple as well. And by the way, this list is, you can say, larger than life. I can spend hours and hours of talking about list. So here, this is just a brief introduction of list. We need to have a few more tools in our hand to talk more about list. So after maybe 1 or 2 modules, we'll come back to the details of list and tuples and dictionaries as well. So here, this is just an introduction of list and tuples. So here I'm going to define tuple. So let's say tup equals to, this was the sign for list. For tuple, this is the sign, right? So I'll say 1, 2, 3, 4, 5. Cool. And then I'll say output the tuple. So here we go. This is how our tuple looks like. I can also say tuple get me tuple of 2. So it will get me 3, because this is 0, this is 1, and this is 2. Cool. But I cannot say tuple of 1 equals to maybe 10. Here we go. It gives me the error. It says that tuple object does not support item assignment. So you cannot assign a new item to a new number to any of the items that are available in the tuple. So tuple is basically immutable data type. right? So this is the difference between mutable and immutable data type. This is the main difference between list and tuple. Rest of the thing is almost same between list and tuple. Let's briefly talk about dictionary and sets over here, and as I said in last video as well, I'll talk about these data types in these data structures in much detail in upcoming modules. So here is just introduction of dictionary and set. So in the dictionary, you have two things, key and value. Every value is identified by a key, right? So if we go back to our coding environment and we try to define a dictionary, by the way, what is the need of dictionary? Here in the list I have a collection of different datas, right? And it could be a collection of different data types as well, but a human being will be much confused in order to identify that this 4 belongs to what is this 4, what is this 9, right? So the dictionary comes into play, and the way we define the dictionary is we say DCT, and here what we do, this is the symbol of dictionary, these flower braces, and we need to first of there has to be a key value pair, right? So this this colon sign basically differentiates between key and value. The left hand side of the colon sign is going to be the key, and right hand side of the colon sign is going to be the value. For example, the key is going to be name and value is going to be, let's say, my name, Zia, right? And then comma. So this is basically one item of dictionary, and then the second item you can say the age, and age could be obviously in integer as well. So let's say age is 15. Cool. So if I say DCT, show me the dictionary, this dictionary looks like this, and I repeat, this colon differentiates between key and value, and comma differentiates between items of the dictionary. Now what if I want to access Zia? So I don't have to do something like dictionary of 0 or dictionary of 1. No, now I have some meaningful indices over here. So I'll say dictionary of name. Here we go. Cool. I can also say let's say in a print statement, I'll say print. So in one statement I can say name is colon, and this is going to be the name, and then the next string says age is, here is going to be the age, and how can I fetch the age? I'll say simply DCT, that is my dictionary, and here I'll mention this age, right? So since this is a string, so I'll add string and age. I'll run it. Here we go. So name is Zia, age is 15. Cool. So you can define as many pairs as you want. This is one pair, key value pair. You can define as many pairs as you want over here. This key can be any integer, this key can be any string, whatever you want to put over here. Same goes out with the value as well. So this is how you can define a dictionary, and you already know how to define tuple, you already know how to define list. Now let's talk about sets, right? So this set is, let's say, s equals to so this is basically a typical mathematical set, right? The mathematical definition of set comes over here. So again, this is denoted by flower braces. You might be confusing that, okay, dictionary is also denoted by flower braces, set is also denoted by flower braces, then how this Python will be able to understand whether this is a set or a dictionary? So in dictionary you have these colon signs, so you have this key value pair that differentiates the dictionary and set. In set you simply define the values like this, right? And you can also have strings as well, maybe hello, and then you can again have the numbers like this. Cool. Okay, so we know that in mathematical set there cannot be duplicates. So here you can see we have duplicate, one is repeating over here, or we can add maybe another one, but it will only consider one once, right? If I run it, here we go. So 0 1 2 3 9 and hello. So order, this is not an ordered data structure. List is an ordered data structure. The order that you have defined over here will be considered, and tuple is also an ordered data set, so order will be considered over here, but this is not an ordered data set. this set is not an ordered data set. Cool. Now does not matter how many times a value is repeating, it is going to ignore these values. You can also, so if I say s dot, by putting dot over here you can access different functions of s. So I'm putting dot and then I'm hitting tab button on my keyboard, tab button, right? So I'll hit tab button, it opens up the suggestions for me, right? So you can see these are all the functions that are associated with sets. We will talk about these functions in much detail in upcoming modules, so don't worry about that. Overall you can see this, there is a union function, and if you remember the maths of your school time, we used to take union of two different sets. We can do it over here as well. We can take intersection as well. We can use pop, remove, add, clear, copy. I mean, a lot of different functions of sets, but in upcoming modules. Let's talk about a few rules. You cannot just name any word to name your variables, right? There are some rules that you have to follow in order to name your variable. For example, it has to be a valid character. Then the case sensitivity is very important. If you're naming your variable like number, number, then if you're using if it is starting with capital M, then it is a different thing. Then if it is starting with a small m, then it is a different thing, right? So case sensitivity is also very important. Then it has to be descriptive and readable. Well, this is not a requirement by Python compiler, but Python community says that you should not be naming your variable like XYZ or ABC or something like that. It has to be descriptive, it has to be readable. Just like you don't, if a kid is born, you don't name it like ABC or XYZ, right? You give it a proper descriptive and readable name. Cool. And then avoid starting with digits. You cannot start the name of your identifier or variable with a digit, right? You can use digits surely inside somewhere inside or ending of the name of the variable, but not in the beginning. And then avoid leading underscore. You can use again underscores inside the variable name but not in the beginning. And finally, you cannot use Python keywords or reserved words as the variable names. What are the keywords? What are the reserved words? So keywords or reserved word are those words for which Python has some predefined meaning. For example, print. Print has some predefined meanings. So you cannot use print as the variable name. Now let's talk about operators in Python. So there are basically three types of operators: arithmetic operators, comparison operators, and logical operators. We have already talked about arithmetic operators, so let's have a quick recap how they look like. So basically we have these, six kind of arithmetic operators: addition, subtraction, floor division. By floor division we mean if we divide, let's say if we have 5 divided by 3, the answer would be in floating point value. But if you don't want the answer in floating point, you can use this floor division. This will get you the floating point free answer, or it will get you an answer in integer format, right? Then we have simple division, we have multiplication, and we have exponential, or this power sign denoted by double asterisk. So let's move on to the comparison operator. This is a very, you can say, important thing in Python. Maybe the way I'll explain it over here, it will look like it is not that important, but believe me, this is sort of a stepping stone towards, or you can say this is a building block of any programming language, right? So maybe right now you will feel like it is not that important, but in next module you will really see the importance of these comparison operators, because these comparison operators are used in decision making process. Yes, your programming language sometimes make decisions as well. So we have mainly 6 type of comparison operators. Equal to operator, that is denoted by double equal to sign, right? So you might be wondering that, hey, single equal to, that is actually equal to sign in mathematics, that is an assignment operator in Python, and when it comes to the equal to thing, you have written another equal to sign in front of it. But yeah, what can I do? That is done by the creators of Python, right? So we have an equal to sign that is denoted by double equal to operator. We have not equal to, that is denoted by exclamation mark and then followed by an equal to sign that says not equal to. Okay. Then we have greater than sign that helps us in finding out if one value is greater than the other value or not. Then we have less than operator, that is the opposite of greater than. Then we have greater than or equal to operator, right? So this helps us finding two conditions. If a certain value is either greater than or equal to the second value or not, right? And then we have less than or equal to operator, that is the opposite of the previous one. So it helps us finding out if a certain value is smaller or equal to the second value or not. Now, one thing that we need to keep in mind is the output of all these comparison operator is always going to be either true or false. That's it, right? So it will never be like either true or false or something like. It will always be very clearly either true or false. And when we say true or false, it comes to the data point, a data type that we skipped last time, that is the Boolean data type, right? So there is another data type that we left deliberately last time, obviously, so which is Boolean data type that has only two values, either true or false, right? So this comparison operator actually works on the principles of Boolean values. It outputs its result in the form of a Boolean value. So enough of talks, let's come to the Jupyter notebook, right? So here, let me mark down this cell for the heading. So I'll make it markdown, then I'll say hash sign, and then this is comparison operators, right? Then I'll run it and it will become my heading. Cool. So first of all, let's start with equal to sign. So if I say 1 is equal to 2, what should be the output? 1 is equal to 2 or not? Obviously not. So it will output false. Cool. If I say 3 equals to 3, output is true. Why? Because that is true. Simple. And then if I say, let's say 3 is not equal to 3. Now you tell me it is true or false. Obviously it is false. 3 is not equal to 3. No, it is false, because 3 is actually equal to 3. But what if I say 1 is not equal to 2? That is true. Yeah, 1 is not equal to 2. I agree. And then if I say, and moreover, we can play around with the variables as well. For example, if I have num1 equals to 5, num2 equals to 7, right? So I have these two numbers. Now, if I say num1 is equal to num2, what should be the answer? False, obviously, because num1 is 5, num2 is 7, so 5 is equal to 7, obviously false. So if I say num1 is greater than num2, right? This is the greater than sign, right? So num1 is greater than num2, is it true? You tell me. No, it is not. It is not true, because num1 is 5, so 5 is not greater than 7. Cool. Okay. And what if I say num1 is smaller than, now this is the smaller than sign, smaller than, let's say 10. Is it true? Now num1 is 5 and 10 is greater than 5. Yeah, I mean 5 is smaller than 10. Here we go. So that is true. Cool. Moreover, we can do something like num2 is, what is num2 by the way? Let's keep it in screen. So num2 is 7, right? So num2 is greater than or equal to 7. Is it true? Yeah, it is true, because num2 is basically equal to 7. So we have both of condition. So which one, I mean, whatever condition is true out of both of these conditions, it will return true, right? So can we say num2 is greater than 7? Is it true? 7 is greater than 7? No, it is false. Why? Because 7 is actually equal to 7, not greater than 7. So if we'll say num2 is greater than or equal to 7, then it works. Then it is true. But if we say it is simply greater than 7, then no, it is false. Okay, so we have these values over here. Let me add a few more cells. Okay, so now what if I say num1 is less than or equal to num2? Now you tell me, is it true or false? Because num1 is 5, num2 is 7. So 5 is less than 7? Yeah, that is true. So if this condition, less than condition, is true, then we don't have to even take care of the second condition, because it is going to output true. Cool. So this is how we can work with the comparison operator, and the output of comparison operators is always either true or false. For now, you only have to remember these two things. The output of comparison operator is going to be true or false, and the second thing is we have these 6 kind of comparison operators. That's it. Now, where we have to use these operators, please bear with me for just a few more videos, and you will find an astonishingly beautiful usage of these comparison operators. Alright, so let's talk about logical operators here. So logical operators are basically, you can say, post-requisites of the comparison operators, or you can say the comparison operators are the inputs to the logical operators. Now, what am I saying? The thing is, you can combine multiple comparison operators in order to make one statement, right? So for example, there are 3 types of logical operators: and, or, and not, right? So if I say true and false, the output would be false. But why? Let's see. And by the way, interestingly, if I say true and false, output would be false. But if I say true or false, the output would be true. Why? So let's look over here. So here I have all the possible combinations that we can have in 2 variables, and this is called basically truth table. So if we put and, so let's say here we have 2 possible outcomes, variable 1 and variable 2. So let's consider this first scenario. So first variable says true, second variable also says true. So the answer of true and true is going to be true. So in order to make a true in AND operator, all the conditions have to be true. And if any of those conditions is going to be false, then the output is going to be false, right? So if I say true and false, so it is going to be false. False and true, it is going to be false. False and false is surely going to be false, right? So if we are using AND operator, all the conditions have to be true. Whereas in OR operators, at least one of the conditions has to be true. So true and true, great, both are true, so it is going to be true. So true and false, so at least one is true, so output is going to be true. False and true, again, at least one is true, so it is going to be true. False and false, none is true over here, so the output is going to be false. Cool. And finally, we have not operator. That is a very simple thing. So whatever is the input, it actually you can say takes it outputs the opposite of the output. For example, input is true, output is going to be false. Input is false, output is going to be true, right? These things may be not very much clear over here. That is why we have Jupyter over here. And Jupyter, let's see. So here, if I say true and false, false with capital F. And by the way, you can see it is turning into green, so these are the reserved words. So true and false is going to be false. Why? Because if we are using AND operator, then both of the conditions have to be true in order to get the true output. So true and true, it results in true. Now look over here. If I say 5 equals to 5, what is the answer? Answer is true. Cool. And I say 6 is greater than 7. The answer is false, right? So this is true and false. So here, if I say, and I make it in braces, and then I say and then I have another braces, and I copy this over here. Cool. Now this is true and this is false. You tell me what is going to be the answer. Answer is going to be false, right? Because true and false is going to be false. But what if I say 6 is greater than 4? Now this is also true. And if I say 6 is greater than 4, now this is true, so the output is going to be surely true, right? And if we go to the previous case where, let's not change it. Let's just copy this. Come on. I want to select you, buddy. Okay, so here, now if I say or, right? So this is true, or this is also true, so it is surely gonna be true. But what if this is false? If I make it 6 is less than 4, now this is false, correct? But this is true. So what is going to be the answer? Answer is going to be again true. Why? Because we are using OR operator, and for OR operator at least one condition has to be true. So here we have this one condition is true, so it don't care about the second condition. Cool. So this is how we can work with the logical operators. So finally, I'm not gonna take a lot of time in operators, so this is the final slide, I promise. Okay, so we have assignment operator over here. This equal to sign refers to assignment operator. We already know that it assigns the value that is on right hand side to the variable that is on left hand side. Cool, we know that. But we also have add and assign operator, and we have subtract and assign operator. We also have multiply and assign. We also have divide and assign, and so on and so forth. You can make a combination of assignment and almost all the arithmetic operators. So how does it work? So add and assign operator. So if I say x plus equals to 5, it is equivalent to x equals to x plus 5. So basically it adds up the previous value of x and 5 together, and it stores these values in x, right? So let's do some practical. Okay, so if I say x equals to maybe let's make it 5, and then here I say x equals to x plus 2, right? Now in third line, what should be the value of x? So here x is 5. Here I'm saying that, let's just talk about this part. I'm saying that x, which is 5, so 5 plus 2 is going to be 7. So this expression will be replaced by 7, right? And now it is an assignment operator. So 7 will be assigned to the variable x over here again. So basically this variable x that has the previous value 5, so 5 value will be overridden by the new value that is coming from here. So now the value of x is 7, and 7 will be the output. Cool? Simple. Now we can replace this line with this thing. So if I say x plus equals to 2, right? This line is equivalent to this line. So what it will do is it will first add 2 into x, and then the result will be stored in the x, right? So now here is a bluff question. If I execute this and then I output x, what is going to be the output? Tricky one, right? 7? No. 9. Why? Any guess? Because here the latest value of x was 7, and now this x is basically 7, and I am adding 2 into 7, that makes it 9. Cool. And again you can so you can do the same thing with not only addition operator, you can do the same thing with subtraction operator as well, and now it will become 7, right? You can do the same thing with multiplication as well, right? So basically it was 7, right? So 7 multiplied by 2 is 14, and 14 is stored in x. So if I output, it becomes 14. Cool. So this is how our assignment operator works. So that's about it from module 1, and you will see a lot of hands-on practical activities in this is the end of module 2, and you will see a lot of practical activities in module 3. So I'll see you there.